files that were created during that operation and so forth, or closing database connection and so forth. So usually what we should do, any class that requires that kind of job should implement this iDisposable interface. Okay, it should implement the iDisposable interface, and it should also provide the implementation of the dispose method. So every time before the object is garbage collected, this dispose method will be executed by the runtime, and then that will do the cleanup chore. Whatever code you have written, like closing files or deleting temporary files or closing database connection or anything else that you want to do, will be done by the implementation of this dispose. So actually this service will be created and it will be displayed, but before it is destroyed, it will check whether it is implementing any iDisposable interface and providing the body for the dispose method or not. Then it will execute it. So first see that it may and every time it will incur some overhead. Okay, so basically one drawback is overhead. What is the overhead? Overhead of creating instances for every time client request comes. Second is okay. Now what is the benefit? Now the benefits are like, if you don't do this, suppose for every call, suppose for every four different requests, okay, for every 4 different requests, if we have the same instance, okay, instead of 4 instances, there is a single instance serving the client. But now what happens if the client is not closing this? Okay, suppose the client is not closing the connection, then this instance will remain in memory. It will not be garbage collected. And whenever this instance will remain in memory, it may also occupy some resources. For example, it might already connected to the database. Okay, it has already connected to the database and it has established the connection, and those connection will be kept in memory. And likewise, many clients are there, and if they are not closing the connection, once the job is done, it will unnecessarily occupy the many useful resources in memory, and that way it is not recommended. Because see that on the database side, what happens if there are say 1,000 connection at a time, it can support only say 1,000 connection. Now 1,001 client comes, then this database will deny the request because already 1,000 requests are in process. Okay, it is serving 1,000 clients. I'm only giving this example. This number may be larger than this 1,000. So even though this service is not using, or this service instance is not utilizing this database, still the connection is there. Okay, connection is established and it is not doing any useful work. And it is the database is not allowing the new client to connect it to the database. So here DB server, database server, has some limitation. Okay, likewise there are many other resources where it is like it has opened some file, and if it is can be opened in exclusive mode only, then the other processes or other services cannot use it because it is locked by one service and so forth. And right now we are not considering the synchronization issue. Otherwise, if many services are trying to access the same database or manipulating the same table or records, then there is a locks are there. So database lock will prevent the other services from using that particular resource. So that's why there are some drawbacks of this also. Because if you go for a single service serving all the requests of the same client or same proxy object, then it might be the waste of resources. Okay, fine. And another benefit is the scalability that you achieve, because now you are no more keeping the service instance in the memory. So the memory is not full. Whenever the service client request is served, it will be automatically destroyed. Okay, every time the client request is served, it will be destroyed from the, as soon as it has served the client, it will be destroyed. So memory usage is less. So likewise, these are some of the advanced optimization issues is to be considered when you are going for real life project. Okay, when you are working with the real life, at that time you need to think about the issues like scalability. So if you go for this per call, then it is more scalable without per call, because in the scale you do not have multiple instances at a time. And even though there are many clients, if they don't close the connection, they will be automatically, the instance would be, service instance would be removed, or it would be garbage collected as soon as it serves the request. And there is no more, it will occupy the useful resources. It will not keep the connection open to the client, to the database. So it will help in scalability. Okay, it can handle more clients than possible. So these are the some of the benefits and drawbacks. And okay, I think one more benefit is it would be useful for the transactional system. In the transaction system, what happens? Basically, where we support the database transaction. Okay, so there you simply do some work and maybe atomically, and it will follow the acid property, and the transaction is over, and then it is free. Okay, so the service instance is free. So either the transaction would be successful or it would be fail. So in the transactional kind of application, this per call kind of service is very much useful. Okay, fine. So next one is the per session. Okay, per session is, that means for the same client, same proxy object, same service instance will serve the request. So here you can see in this figure that like we told that we have service client, sorry, we have the service client object sc sc.add. So basically this call will be served by the, so as soon as it receives the request, it will create an instance, and then that instance will be serving the request. Now the reply will be sent back to the client. Now it invokes another operation, sc.divide. Right? Then also the same instance will serve the request. Likewise, so it is not creating another instance, and that instance will remain in memory until this client object is explicitly closing the connection via the close. Otherwise, this instance remains in memory. Okay. Similarly, for the other clients, for every client, there is a one and only one instance. Okay, unique instance rather. So for every client request, there is a, so it is something like one-to-one mapping, and it will also support the session. Okay, because now it is uses session. You can see that because over the same session, okay, over the same session, this client request starts coming and they are handled by the service. Is it clear the difference between per call and per session? And one more difference to note, that if this client creates another proxy object, then new instance will be created. Okay, so this is SC. Suppose it creates another object of service client, say SC2. Okay, then it will create a new instance. Okay, at that time it will create a new instance, even though client is one, same client, but the proxy object are different. Okay, two objects are different. This is SC, we can say SC1, SC2, SC3 and so forth. As many proxy objects are there many number of service instance will be present on the service side. Okay, so same we have already discussed the advantage and disadvantage of per call and per session. If you have single instance, suppose this operation is finished, still the service instance will remain in memory. And in case if it has established the connection to the database or opened some file, everything will remain in the memory. and they will be wasting the memory. Okay, unnecessarily it is a wastage of memory and useful resources like database connection or some files are created likewise. And finally, we have the third kind of instancing. It is called singleton. Okay, singleton. All of you know singleton? Yes, everyone. Anybody who doesn't know singleton? Okay, as the name suggests, singleton means there is always one and only one instance. We can never have more than one instance of the service. So irrespective of the number of client, irrespective of number of proxy object, on the service side, one, there is only one instance that will serve the client. So as you can see from the diagram that there are multiple clients, they are talking with a single instance. Okay, so on the server side, there is only one instance. Okay, one and only one instance. That's why it is called singleton. Okay, so here even within the client there may be two proxy objects, SC1 and SC2. Still, both of them would be served by the same instance. But then it should be used in a special condition only, because now there is a problem of here. Okay, because at a time it can serve only limited number of clients. So the same instance, so that is called concurrency issue. We'll talk about it in the maybe in the next lecture. How many concurrent requests an instance can serve? Okay, so that is we call as a concurrency issue. So yeah, we need to identify there will be some limitation. So at a time only a limited number of client can be served. And again, see that for the different object, it is not creating an instance. So that will also sometime technically in WCF they also call as the throttling behavior. Okay. They call it as a throttling behavior. Okay, in other literature also you will hear this word, technical one, throttling. So again, in a special case, you can use the singleton, because now the benefit is you have single connection to the database. You don't require multiple connection. All the clients are served. Then state can be easily managed. So both in singleton and per session, state can be easily maintained. Okay, because the connection is not terminated. Over the same session, we can get the reply. So suppose there is a two consecutive requests, request 1 followed by request 2. Okay, so there are two requests. So on the service side, we can know that request 2 came after request 1. Okay, so the ordering can be maintained, or the output produced from the previous can be also be known while the second request comes, and so forth. So session, you know very well the benefits of session. Okay, so because the sessions are there, we need not maintain it at the application level. Otherwise, in HTTP we have to maintain it on our own. Okay, HTTP, it is stateless. So sessions are maintained by the application, not by the protocol. Okay, HTTP doesn't support the session. Okay, it is a stateless protocol. So there is no distinction between the previous request and the next request. It will forget it, and that's why we require the database to store the state of the system in a persistent manner. Okay. So I hope these three are clear: per call, per session, and singleton. See that performance wise, what we have discussed, like see that depends upon how much memory you have, how many concurrent requests you are getting. If you want the scalability, you should go for per call. Okay, so there is not single answer. Usually, normally either you are using per call or per session. Singleton is used in a special case only, and you don't want to manage, or there is a limitation on the server side of database, and or there are very few requests are there, limited number of requests are there, then you go for singleton, because with the limited resource you can perform better with the singleton. But in practice you will find out per call or per session. If you don't want to manage session yourself, go with the per session. Okay, but if you can manage the session yourself, you can go for the per call. Okay, here the responsibility of managing session, because now see that between two requests it doesn't know whether which was the first request, which was the second request, the ordering, or whether there is any state change. So that is the job of the programmer to handle this. So it is not like that per call we cannot manage states, or we cannot manage sessions. Okay, we can manage sessions via managing states. Okay, so managing states is the programmer's responsibility. Okay, it should be done by the explicitly by the programmer. Okay, so for every time a request comes in the implementation, what you do, you restore state. Sorry, I think. And do some work and again save state. I think here the let me clear it out. Okay, in the implementation, what you do, 3 steps are needed in the implementation. You need to restore state, then you do some work and then save state. In operating system, all of you know context switching, process context switching. Okay, so what the operating system does, whenever there is a switch from one process to another, it will restore the state of the new process. Once it does, once it performs the operation, then after the before the switching to the new process, it will save the state of the currently running process. Okay, so these are similarly you have to have some JS code for saving the state of the system. Normally we save the state in the files or the database. Okay, so for that what we can do, there is a service behavior. Okay, there is a service behavior part. And it has one property called instance context mode, and there are 3 possible values: per call, per session, and single. Single is nothing but singleton. Right? So you set this value and you get the desired effect. Okay? So for example, in these 3 cases, this per session is default. Okay, so by default it is per session, and that's why we need not to manage the session ourselves. So you can see that if we create a say class my service that will implement say our interface my contract, then by default service behavior is this is instance context mode dot per session. Okay, it is per session. Basically it's an enum. Okay, it's an enum. Instance context mode is the enum. We see that all these 3 code snippets are equivalent because the per session is the default value. Basically this service behavior is to be set, and that will be not known to the client. Okay, client will not know whether it has been managing this per session, per call, because to the client it will look like an instance is created and it is getting the reply. So here all these three code are equivalent. Okay, so that's why either you don't write, even if you don't write service behavior, by default it is per session. Okay, there is one more called session mode. At property, again there is an enum defined in the WCF assembly, and the session mode can have three possible value: allowed, required, and not allowed. So whether you want the session to be established or not. So see that over the HTTP protocol, normally the sessions are not allowed. Okay, but it can be emulated. It is possible. WCF can emulate it. Then there are TCP and IPC protocol. By default, the protocol supports session. Okay, normally we use these protocols when we want to have the session. Okay, so that means there is a client and service. Whenever the connection is established, and the further request will be on the same channel. Okay, it will not create a new channel. It will not create a new instance. Over the same channel, all the requests are coming. So session is managed, and even it can manage uh, the messages. It can manage the messages. It can also manage the ordering of the messages, which was first, which was second, and so forth. So that can be managed. So these protocols, I think whether it is covered in CN or not, CN subject, TCP protocol. Yeah, so okay, if you know, then it is fine. So the TCP supports that, and it supports session. So here by default HTTP doesn't support, but it can be emulated by the WCF. So whether you want to allow the session or not. So normally in per call, sessions are not there. Within the per session, sessions are automatically established, but usually we are using this TCP or IPC. IPC means pipe. Okay, here a name pipe. So it is allowed, required, or not allowed. So depending upon the type of instancing you want, you can set it. And the default value is allowed. Okay, default value is allowed. Allowed is the default value. So that means whenever we are defining our interface, okay, whenever we are defining our interface, which is annotated with the service contract, it can have this value session mode to be allowed, not allowed, or required. Okay, there are three possible values: allowed, not allowed, or required. So default value is allowed, and that's why see that the sessions are by default supported. Allowed means it depends upon the type of binding that you are using. Okay, normally this, like I told you, if you are using the binding type to be TCP or IPC, it will allow the session. If you are using HTTP or suppose WS HTTP binding, then it will emulate the session. But if you set it not allowed, then you cannot use TCP or IPC, because by default they are supporting the session. But suppose you are using basic HTTP binding, it doesn't support session. Okay, it doesn't support session. Then you can use not allow. Okay, then you can use not allow. You can explicitly say that not allowed. But if you are setting TCP, then you can use either allowed or required. Both are fine. If you are using net TCP binding or net name pipe binding, then you can use either allowed or required. And it would be better, you can explicitly say that it is, I want the session to be established or session to be maintained between client and service. Okay, so far we have not seen because we are going with the default values and it was fine. But now depending upon the application, whether we want our service to have the session or it should be per call or instancing should be per call or per session, we can configure it. Okay, so for your reference, this is the table which contains the different binding type, the session mode, whether it is allowed, not allowed, or required, and the context mode. Now we'll call it as a context mode, whether it is per call, per session, and whether the service instance will be created per call or per session. For example, we have discussed that if we are using basic HTTP binding, then session mode can be allowed or not allowed. It cannot be required. Okay, it cannot be required. The reason is it doesn't support session. So it is invalid. If you try to use this combination, the WCF will throw an error. Okay. If you try to go with the basic HTTP binding and you use the session mode to be required, then it will throw an exception. Okay. It will throw error. So usually these are the valid values. Okay. These are going for the valid combination. So there are so many combinations are possible, but this table lists down some of the valid combinations. So with the basic HTTP binding, you can go with either allowed or not allowed. And you can either the instance context mode to set it per call or per session, but the behavior would be per call. Okay, so every time any client request comes, a new instance will be created. Similarly, if you are using TCP or IPC, you can go with either per call or per session. Okay, you can go for the per call or per session. So here the value could be allowed or required, but it cannot be not allowed because these are meant for session. Okay, TCP protocols and these IPC protocols by default are meant for session, managing sessions. So the value should be either allowed or required. So by default it is allowed. That's why all the programs were working fine. Okay, all the programs that we have seen so far are having allowed. Okay, the value allowed. So most of the bindings supports allowed, except this last one. You can see that when we are using WS protocol like WS HTTP binding, WS dual HTTP binding, where we are using message security or reliability, then it should not be session mode, should not be not allowed. Okay. Okay, here there are two combination, either where you want per call. Okay, if you want per call, then you go for not allowed. But if you want per session, then you go with the allowed or required. Okay, allowed or required. But see that again, in most of the time, either you are going two combinations are either you are going for HTTP binding, which can be, see that this basic HTTP binding is old. Okay, this is old protocol. So unless you want it to be compatible with very old web services, then you are using it. Otherwise, we are not using it. Then next is you are going for WS standard. So it is WS HTTP protocol. Okay, you are going for WS protocol. Okay, so then you can use WS HTTP binding. And second is either if you want session, then you are using TCP or IPC. So there are three possible combination. Either you are going for the basic HTTP binding, either you are going for the interoperable binding like WS-HTTP binding or WS-HTTP binding, or you are going for uh, TCP or IPC binding where it supports the sessions. It may sound too complex, but it is not that much, because in real life you will have very few combinations that you will be implementing. Unless it's a special application or special requirement, you are not going for all the combinations. Many of the combinations are invalid. They will throw exception if you try to use that binding with that session mode or context mode. So now we'll see one example application to understand this instancing mode, whether it is per call, per session, or singleton. Okay, single. So first we'll create the service. Let us directly jump to the implementation part. We have only one operation, increment. Okay. So this is the interface. Okay, our service contract, I service, and this is our service contract. And you will see that we have not provided instance context mode. So by default it is, yeah, okay, no, in here we'll see that in the implementation we'll provide it. Okay, in the implementation, by default it is per session. Okay, if we do not provide this, so far we are not using service behavior. Okay, but now we are using this service behavior attribute. Okay, with the property instance context mode, which is set to per call, because by default it is per session. And that's why, suppose we go with the per call, that means every time a client request comes, sorry, client request comes, a new instance will be created. This is on the service side, this is on the client side. Every time a new request comes, a new service instance would be created. And we are implementing this increment operation having a counter value, and we increment the value and return that new value. So there is a very simple implementation just to check whether we are getting the response from the same service instance or from another service instance. So every time we call this operation, what do you think? What should we get? Every time there is a client request, what is the value returned? Because now we are using per call. What do you think? If we implement this, if we create this service, if we host it, and if we create a client, and if the client is making this request increment operation, then what should we get as a reply? I hope that my question is clear or not. What should we get? Which value we should get? See that right now we have not initialized. Then what should we get? Currently we have not initialized to some value. Okay, by default they will be initialized to 0. So even if you don't initialize it, by default they are initialized to 0. So that's why always we get the value 1 as the reply. And then we know that it is per call. If it is per session, then instead of per call, if you set it to per session, then correct. We should get the next values 1, then 2 and 3. Okay. Depending upon whether we are setting. So here we'll get 1, then we'll get. So now new instance will not be created. In fact, okay, this in per session, if we call it first time, it should return 1. If we call it second time, it should return 2. If we call it third time, it should return 3, because now this is the same instance. Okay, the same instance, the counter value is a private variable. Okay, so we are getting the successive value of the counter. Okay, so I think you understood it. Any doubt? Any doubt so far? Per call, per session, and one more is there. What is that? So three possible NM values: per call, per session, and it looks like everybody is hungry. Correct. It is singleton. So what is the behavior if we set it to the singleton? Let me have one more color. If we use singleton, what should happen? So there is a client and there is a service. If it is asking for the increment operation, it will return 1. Again, if it is asking for the next, it should return 2. But suppose there is another client, if it is asking for the increment operation, then it should get which value? It should get 3. Okay, because it has already been incremented to 2. Again, there is a third client which is asking for the increment operation. It issues increment operation. It should get value 4. If the same client request again, it should get 5. If these previous clients get invokes this operation, it should get 6. Clear how it is working? Any doubt? This is what our expectation. Okay, our program or application should work according to the theory that we know. Okay, so now just build this service, then we will host it on some. I am just skipping those slides, and right now see that what I have done in the host, I have not provided the base address. Okay, base address. Okay, let me take some different color. Base address is not provided. Okay, we have not provided base address, and that's why this is an absolute address for our HTTP binding. Okay, WS HTTP binding, it's an absolute address. Similarly, to download the metadata, we have provided the address, okay, through another property, HTTP get URL. Usually we do not provide this because we have the base address. Is it clear? Normally we don't provide this property because we are defining the base address. But right now in this example on the host side, we have not provided the base address. So that's why for all the endpoints, the address must be absolute. Whether it is TCP or any other endpoint, it should be absolute. Finally, the host is running and then waiting for the request from the client. We are defining this client having a single button. So basically, when the user clicks on this button, it should invoke the increment operation, and whatever the value in some variable, okay, store it in some variable and display it, and it will call it again, store it in the variable and display it. So we call this operation twice. When the button is clicked by the user, it should invoke this operation, increment operation, twice, and whatever the return value, it should display. Okay, so that's what we want. So this is the implementation. I hope that it is readable. We create the new service client object, and then we invoke this increment operation twice, and we use the message box.show method to display to the user. Okay, so if there is a client and the service, we call it, what we get, 1. Second time if we call it, it will create a new instance, we should get it or rather, sorry, yeah. For the first call, we should get the value 1. For the second call, it will create a new instance. What should we get as the return value? This is the first call. Then we have the second call. For the second call, the return value of increment should be 1 or 2. It should be 1 because now it is completely new instance and counter is initialized to 0. Here also counter is initialized to 0. It is incremented and the return value is 1. Here also it is incremented and the return value is 1. Okay, so we should get this value. You can see that just we are testing that this is value 1 and 1. Okay. Now we change this instance context mode to be the per session. Then the behavior should change. And right now, in fact, it is we are changing it on the service side. Okay, we are not changing the client. We are not changing the client. So there is a service. Then we have host. There is a client. Okay, so if you are making change into the service, it should be known to the host. Okay, so we need to stop the host, running host, because the host is running, and then we compile it and then we update the DLL file. Actually, there is no need to update the DLL file if the address is same. Okay, if the path is same, there is no need to update the DLL file. But anyway, you will see that I am specifically removing that particular reference, and then this DLL is again re-reference, but unless it should not be done if the path is different. So again, we run the host and run the client, and you will see that now we are getting 1 and 2. Okay, 1 and 2. So here you will see that in the same for the per session, you should get the value 1 and 2. Okay, here it is 1, then 2, because the same service instance is replying. Okay, finally, if we set it to the single, so that is the singleton, it should get the value 1 and 2. Now we are directly going to the client, and in the bin debug folder /bin/debug folder, we create a new instance of the client application. Okay, we run it explicitly. Okay, so there should be 2 clients. Okay, there should be 2 clients, and if I invoke this increment operation by clicking the button 1, then we should get the value 3 and 4. Okay, if I create a new instance of the client directly going to the browser, the Explorer, to the file system, then we should get the value 5 and 6. So basically now there are 3 clients. Okay, so same service instance, there are 3 clients, C1, C2 and C3. Okay, this is the same service instance, singleton. So first time we call the increment, we get 1. Next time we call it, we should get 2. Here it calls third time, it is. Here the another client calls it first time, it should get 3, 4. Is 5. Okay, fine. Hope that this is clear. Instance mode that can be set via the service behavior attribute. Okay, it can be set via the service behavior attribute. It can be through the instance context mode. So basically this will determine how the service instance is created on the host context of the host. Okay, that will determine how the instance of the services to be created within the context on the host side. Okay, so basically controlling this number of instances on the host side, and that can be set to equal to per call, per session, or single, right? Any doubt so far? I think I'm done with this instancing board. And we have not changed the session mode, because by default the session mode is allowed. So that's why we can create session, or we cannot. If we do not create session, that is also fine. If we create session, that is also fine. So we have not tweaked that value of session mode. Okay, there was another word, session mode. It can be allowed, not allowed, or required. Okay. Further example and theory, you can refer to the documentation, official documentation, WCF, available on the Microsoft website. Okay, fine. If there are no questions, we can uh, terminate. We will conclude today's session.